Hey there, if you see a massive system of nonlinear equations on the digital set, your first instinct might be to instantly fire up Desmos. But what if I told you that relying on the calculator for every problem is actually a trap that will cost you precious time? Welcome back to Bhargav Academy. Today, we are going into full exam mode to speedrun 10 of the hardest nonlinear equation problems the college board can throw at you. In this video, we are settling the ultimate debate, Algebra versus Desmos. I am going to show you the exact shortcuts to identify when the built-in calculator is your best friend and when doing it by hand using the discriminant is the absolute fastest way to secure those points. Let's lock in, beat the clock and crush problem number 1. Let me erase this first. Let's get going. So here is the first question. 4 into x plus 3 is equal to 16 into x minus 5 into x plus 3. What is the sum of the solutions to the given equation? Desmos. So let me type it here. X minus 5 into x plus 3. So what do we have here? He's asking you the sum of the solutions. So minus 3 is one solution, another solution is 5.25. If I add them, I'll be getting 5.25 minus 3 is 2.25. So that is the solution, plus 2.25 is the sum of the solutions of the given equation. Let's go to the next problem. So this is the question, 2x square plus 7x plus 10 equal to 0. How many distinct real solution does the given equation have? So once again, Desmos. Let me type this one. 2x square plus 7x plus 10. How many distinct real solutions? Solutions are those where this particular parabola meets the x-axis. Since this particular parabola is not meeting the x-axis, there are no real solutions for this particular equation. So the answer is 0. Let's go to the next question. So here we have a question. Let me show it to you nicely. We have one equation which is saying y equal to x plus 4. Another equation is y equal to x square plus 8x plus 16. The solution to the given system of equations is x comma y. What is the greatest possible value of y? Again, go for Desmos for this question. You can do this algebraically, but Desmos gives you the answer much quicker. So I am doing it in the Desmos way. X plus 4. Remember, we are in the exam mode. So this is how you should be solving the problems when you are in the exam, because this is the fastest way to do these problems. So what do we have here? The solution to the given system of equations is x comma y. So what is the greatest possible value of y? So please look here. These are the two solutions we have. He is asking you the greatest value of y. So this coordinate is what we are interested in, because here the value of y is 0, but here the value of y is 1. So the greatest possible value of y is 1 following this point, minus 3 comma 1. So the answer is this. Let's go to the next question. So this question, 12 by w is equal to 12 by x minus 12 by y minus 12 by z. The given equation relates the positive variables w, x, y, z. So all of them are positive. All right. Which of the following equation is equivalent to x? So it's basically asking you to find the value of x. Please don't do this on Desmos. Let me show it to you how this can be quickly done. I can happily cancel 12 on all the sides because it is there everywhere. And from there I can take So he is asking me to find the value of x, but I have already found the value of 1 by x. So I should take the LCM or LCD, whatever you want to call it, and then if I simplify this, so if I do the inverse of this, I should be getting the answer. So my answer is WXYZ. So C is looking like my answer. So let me quickly go to the next question. So here is the question: minus x square plus bx minus 400 equal to 0. This is the equation. In the given equation, b is a positive integer. Okay, the equation has no real solution. No real solution. So this equation should not be touching the x-axis. What is the greatest possible value of b? Let me first try this in Desmos and see how it will go. Minus x square plus bx minus 400, and let me add the slider. So I cannot see the graph here, so I'll zoom out and see if I can see it. Let me increase this to 100 and see if, yes, I can see now something. All right. So what do we have here? The equation has no real solution. So this equation should not be touching, this parabola should not be touching or intersecting the x-axis. So let me, yes, now some luck. I have some luck here. What is the greatest possible value of b? Now I have to be really careful here and see what is happening. If I make, okay, 40 is looking okay, 39 is okay. Now if you see, what is the greatest possible value of b? First let me do it the algebraic way, where the discriminant should be less than 0 because it has no real solution. Because it has no real solution. So b square minus 4 into minus 1 into minus 400 should be less than 0. So this is b here, b square minus 1600 should be less than 0. B square should be less than 1600. If I see an equation like this, I should be knowing that this inequality lies between minus 40 to plus 40. So I know what is the greatest possible value of b. B should be less than 40 and b is a positive integer. So the only possibility is b has to be 39. Now let's try to see if our answer matches, if Desmos is helping us in any way. If you see here, from the algebra we have found that the answer is 39. Let's see if 39 is, where is 39? Okay. If I make this 40, 41, I have two solutions. The question is saying it should not have any real solution. So 40 is not going to work. 41 is also not going to work because it has two solutions. 40, it has exactly one solution. It is touching the x-axis. So again, no solution is the question here. So 40 is also not allowed. Go a little bit backwards. 39 is allowed. Now I wouldn't suggest doing this problem with Desmos because it's consuming a lot of time during my exam. So I want to do this in the algebraic way. Let's go to the next problem. Y equal to 2x square minus 16x plus 45, y equal to 4x plus c. In the given system of equations, c is a constant. The graphs of the equations in the given system intersect exactly at one point, okay, in the xy plane. What is the value of x? Now please read the question here. He's asking you the value of x, not the value of c. So please be careful here. Now this problem, let's do it first algebraically, then we'll see how it will go in Desmos. Okay, I should substitute the value of 4x plus c right here. So that's what I will do. 4x plus c is equal to 2x square minus 16x plus 45. Let me reduce this to a quadratic. I'll bring 4x towards this side and c towards this side. So 45 minus c should be equal to 0. So this equation becomes plus 45 minus c. The original question is, he has given you the two equations and he has asked you to say, and the condition is they should meet exactly at one point. So once you reduce these two equations into a quadratic like this condition becomes that this quadratic discriminant should be equal to 0 because it is exactly at one point. So this quadratic should be touching the x-axis at only one point. So let me quickly write down the discriminant, which is b square minus 4 into a into c. Let me fill in the blanks. B is minus 20, a is 2, c is 45 minus small c. This should be equal to 0. So this is 400 minus 8 into 45 minus c is equal to 0. 400 should be equal to 8 into 45 minus c. So 400 by 8 should be equal to 45 minus c. 8 goes 50 times. So c equal to 45 minus 50, which is equal to minus 5. C equal to minus 5 is the answer. Okay. Let me do this on Desmos and see how it goes. The first equation is 2x square minus 16x plus 45. The next equation is y is equal to 4x plus c. I should add a slider to c. Now here in the question I found the value of c, but he's asking me the value of x. I've still not found the answer. Alright, now let's see here what is the value of. First of all, I have to make sure that these two graphs which I am seeing here, they should meet exactly at one point. So let me do that initially. Let's see if I get lucky somewhere. Not yet. Because I have solved it algebraically, I know the answer should be at minus 5, and at exactly at minus 5, the x value is coming out to be 5. So that is the answer, x equal to 5. So I have used the combination of both to solve the answer. Okay, let's go to the next problem. So y plus k is x plus 18, y minus k is x square minus 9x. In the given system of equations, k is a constant. Where is the value of k? K is sitting here. The system has exactly one distinct real solution. What is the value of k? So let me do this algebraically first and see how it is going. So I'll find the value of y from here and substitute here. So y is equal to x square minus 9x plus k. I'll substitute this here. So x square minus 9x plus k is equal to x plus 18. X square minus 9x minus x plus 2k minus 18 should be equal to 0. X square minus 10x plus 2k minus 18 should be equal to 0. Again, the same logic which we have used previously, we have to use it here because he is telling you exactly one distinct real solution. So this quadratic should have only one root. So the discriminant has to be equal to 0. B square minus 4 into a into c should be equal to 0. B is minus 10, a is 1 and c is 2k minus 18. That reduces to 100 minus 4 into 2k minus 18 is equal to 0. 100 is equal to 4 into 2k minus 18. So 4 goes 25 times. 25 plus 18 by 2 is equal to k, which turns out to be 25 plus 18 is 43 by 2. So that is your answer. Shall we do this in Desmos once and see how it goes? Y plus k, let's see which one is faster. Y plus k is equal to x plus 18. y minus k is equal to x square minus 9x. And then what I should do, I should make sure that both these equations have only one. I have to extend this to 100. Okay. Since I already know the answer, which is 43 by 2 is coming out to be some 22.5. No, 22 to the 4, 1, 3, 6, 26, 3.5. 2 the 4, 21, 1.5. Yes. So that is the exact point where they are meeting, and it's a little bit messy to do with Desmos because it's hard to find this point. So I would prefer the algebraic way here. Or if you want to really do it with Desmos, then the way to do it, I'll tell you. You have to focus on this equation which you have got here. And let me show it to you how it should be done on Desmos. So what do we have here? Focus on this equation which I have told you, minus 10x plus 2k minus 18. Add the slider, and because the question is exactly one distant real solution, so this quadratic should touch the x-axis at exactly one point. So let's try to see. Let's make it happen. Let me increase this value. So 21, no. 22, again no, because it should have only exactly one solution. So you have to go somewhere middle. So 21.5, yes. So that's how you will do it. Because if you take these two equations, things are not working out because it's going to take a lot of time. So I would suggest when you get problems like this, reduce it into a quadratic equation and then substitute that, then type that equation on Desmos and then try to find whatever condition he has given. If he says one distant real solution, make sure the quadratic touches the x-axis at one point. It's much more easier to find that one point with a quadratic rather than solving two equations on Desmos. It can get messier sometimes. So let's go to the next problem, and whenever you type the equations on Desmos, make sure you cross out the slider which I've just shown you, so that whenever you use the value of k again, it comes out to be, it does not take the previous past value. So let's go to the next problem. The eighth one, what is the smallest solution to the given equation? So if the question asks you to find the smallest solution, they're asking you to find the value, then usually Desmos is the best way. Let's see if it works here. X minus 3 squared minus, is equal to 2x plus 18. Now, what is the smallest solution is asking you? So the smallest solution is where this particular graph is cutting the x-axis, which is here and here, but unfortunately it's not showing it to me. Don't be disheartened. What you have to do is, instead of the equal to sign, put a negative sign. Now you have both the solutions exactly pointed out. So these are the two solutions you have. Oh, I'm sorry, this has to be 18. Yes, now we are there. So these are the two solutions. He's asking you the smallest solution, so that comes out to be -1. So that is the answer. How quick it is with Desmos. Let's go to the next problem. So here we have a question, 36x square minus 12a plus 3bx plus ab equal to 0. A and b are positive constants. Quickly write that down. The sum of the solutions to the given equation is k into 4a plus b. Once you see a quadratic equation, you are expected to know what is the sum of the zeros. So let me consider the roots to be alpha and beta for this quadratic equation. So he's telling me that alpha plus beta is sum of the roots is equal to k into 4a plus b. But from the question I can write that sum to be 12a plus 3b, because I know alpha plus beta is equal to minus b by a. Because I have already used small a and small b here, I will be using a different notation here. So from this I can write this. Alright, let me show it to you. From this definition I can write this, and I can also write this, product of the roots is equal to AB, because once again alpha into beta should be equal to C by A. If this is the quadratic equation, A small x square plus B small x plus C, comparing this with this equation, okay. I hope everything is clear. Let me repeat this for you. So this is the quadratic equation we have. This is the quadratic equation. What did I do so far? Sum of the roots should be equal to this based because of this definition, and he has already given in the question that sum of the roots is equal to k into 4a plus b, so I have written that as well here. And then I also know from here that product of the roots should be equal to this, so I have written the same. Now what is he asking me to do? Where k is a constant, what is the value of k? Okay, let me use this equation, see if I can quickly find out the value of k. 4a plus b is equal to, if I take 4 common from here, no, let me take 3 common, so that comes out to be 4a plus 3. Does that make sense? No. B, yes, 12a plus 3b. Now if I compare these two, I can see they are the same, so k equal to 3. That's how straightforward it is. Please don't do this with Desmos because it's going to consume a lot of your time. You should add slider for A, you should have slider for B, and then you have to check the conditions. It's going to take a lot of time. So please don't do this with Desmos, it's going to waste your time. Next. Which quadratic equation has no real solutions? Please don't do this with Desmos, it's going to take time. Use the discriminant concept. Discriminant for this is b square minus 4 into a into c. B is 10, a is 1, and this is minus 25. No real solutions, so d is expected to be negative. So what is the d is coming out to be positive here. So this has real solutions, so this can't be the answer. Let's check d for this. So d for this is b square minus 4 into a into c. B is minus 10, a is 1, this is 25. 100 minus 100, this is coming to be equal to 0. So again, this is not satisfying, no real solutions. Let's check the value of d here. Something square minus 4 into something, let's check. This is minus 10, 4, a is 2, and c is minus 25. So what do we have here? 100 plus some positive value. So again, this is not the answer. Let's check for this. Discriminant is b square minus 4 into a into c. B is minus 10, a is 2, this is coming out to be 25. This is 200, this is negative, so this is the answer. Because discriminant is negative, then only it will has no real solutions. So I think we have come to the end of this video, and let us do a quick recap of what we have done so far. So this, how did we do this with Desmos? Substitute this in Desmos. Let me show to you the Desmos. Is it available? Yes. We have typed this particular equation in Desmos, as you can see here, and then we have found the solutions, both the solutions, and then we have added them. So we have done this with Desmos, and this is the fastest way. Let's go to the next question. How many distinct real solutions does the given equation have? Again, we have done this using Desmos, as you can see here. Distinct real solutions, we have seen from that particular equation that because this particular equation is not touching the x-axis, so it has no real solutions. So Desmos is the best way to do this one, the fastest way. What about this? Again, Desmos is coming to our help here. If he is asking you to solve something, usually Desmos is the best way, especially if he is asking you to solve either x, y, or if he has given you both x and y and he is asking you to solve a particular constant, then please go for Desmos. I have substituted both the equations here, and then I have figured out the value of y. He is asking you the greatest possible value of y, which comes out to be this. No, there is some, yeah. The greatest possible value of y is this, which is minus 3, 1. The y coordinate is 1. Let's go to the next problem. So this, we'll never do this with Desmos. Look at this problem. He's asking you to find the value of x. Simplify this particular equation and find out the value of x. Let's go to the next question. So what is here? B is a positive integer. The equation has no zero. What is the greatest possible value of B? You can do this with Desmos, no problem. You can do this with Desmos. This is something beautiful I want to tell you here. Doing this with Desmos, there is a catch here. The reason is because he has asked you to find the greatest possible value of B. Let me show you where is the trap here. Did I type this? Yes, I did. Let me add this slider. If I added slider somewhere, I want to remove this. Okay, let me add the slider and let me show you this. Now here is what we see in Desmos. Why am I not seeing anything? Okay, let me increase this. Okay, please see here. What is the question? Let's come back. The equation has no real solution, so this particular parabola should not be cutting the x-axis. So I'll be moving the value of x and see where this parabola is not cutting the x-axis. I'm sorry. So here I found a value that it is not cutting the x-axis, and it is coming out to be minus greatest value. B is coming out to be minus 40, and this particular point is minus 20, 0. If you are not aware of this algebraic concept that if b square is less than 1600, then this comes out to be like this, you might be tempted to write your answer as b is minus 40 because you don't know that b can also be less than minus 40. This part you might be missing, this part. If you know that this is what it is, then instead of minus 40, you would be also traveling to the positive side. The positive side as well. And then you would be checking if there is any positive value for which things work out. And they do work out, and that is the answer. So once again, here in this question, the greatest possible value of b. What about the previous question? For this particular question, I would really recommend you to do it the algebraic way, not the Desmos way, because if you are not aware of this point, you wouldn't be checking both the positive and negative sides. You would be checking only the one side. Wherever you get the answer, you might actually mark it, so which need not be right if you are doing it on the other side. Let's go to the next question. For this question, Desmos is okay. You can do it on Desmos. In fact, as we have discussed, Desmos gives us the fastest way to do this problem. Algebraically, it's going to take you a lot of time. And please read the question carefully, whether he is asking you the value of x or the value of c. You get the value of c, minus 5. From there, you can directly plot the From there you can directly plot the you can directly find the value of x. Okay, let's go to the next one. And here I have told you that to find this particular problem, please reduce these two equations into a single equation, a quadratic, and then apply the condition that is given in the question. That way you would be doing much faster. So little bit of algebra and then shifting to Desmos is the best way to do this. Okay, that is the best way. Let's go to the next question. What do we have here? Again, here also you have two equations. He is asking you to find the solution. Plug both the equations, substitute and make them as one single equation. Substitute that in Desmos and you will get the value of k to be the fastest way. So that is the best way to do. So initially with algebra and then shift to Desmos. Apply the condition that is there in the question. It is the fastest way to do. And if you are little bit patient, you can as well, find it algebraically as well and then verify it with Desmos. Now let's go to the next question. This one, Desmos is the best way, clear winner. The only catch here is if you are not getting an answer with Desmos when you type the equal to, don't panic. Shift this particular expression to the left hand side and then you plug into Desmos, then you will get the smallest solution, which is your answer. Alright, let's go to the next one. We are doing the revision again and trying to figure out which is the best way. Okay, algebra is the clear winner here, no doubt about that. Please don't do it with Desmos, especially if you see more than one constant, because you will be adding all the sliders and it's going to take you a lot of time. Please don't do that. And then this question, clearly do it algebraically, it's much faster because you need to type this all the four equations. I think it's much faster. You need not even calculate the actual values. All you have to see is whether this particular set of numbers is positive or negative or equal to 0. It's straightforward. So why do you want to do it with Desmos? So there we come to the conclusion. I have shown you how and where algebra is better, how and where Desmos is better. All right. So as you saw today, hitting a perfect math score isn't just about knowing the formulas. It's about recognizing the patterns, knowing exactly when to use Desmos to bypass the algebra and knowing when the algebra is actually faster than typing it all out, or a combination of both is the ultimate cheat code for this SAT. But just watching me execute these speed runs isn't enough to build your muscle memory for the last test day. You have to try this yourself. Go to the pinned comment right now and download the blank PDF worksheet for this exact 10 problems along with my personal class notes which I am sharing with you. Okay, which of these questions completely tricked you today? Was it question 6? Let me know in the comments below. Make sure to hit the subscribe so you don't miss the next SAT exam mode speedrun. Keep pushing, keep practicing, and I'll see you in the next video. Bye bye.